Welcome back to Zero Dark Emissions. Last time we left off with the installation of the inverters and EV wiring harnesses, and in this episode we will install the onboard charger and DC to DC converter. The onboard charger is fastened to the frame, so this will be permanently installed now, but the DC to DC converter will be fastened to the body, so that is just being temporarily connected for testing. The first thing here are the mounts that will fasten the charger to the frame. These are two identical brackets that will be fastened to either side of the charger, and each will utilize two of the three mounting holes based on how each side interfaces. You can see that the bolt holes for mounting the brackets to the charger are elongated so that they can be adjusted to fit between the two frame mounting points. The first bracket will attach to the front face of the rear chassis crossmember at the passenger side. Here I have already drilled the first of the two bolt holes, and now I am locating the second hole off of this first one. The charger is being mounted as low as possible, such that it just maintains the current clearance under the vehicle and leaves the maximum available space at the top for the electrical connections below the underside of the body. With the hole location marked, we can drill out the second hole. Next, we can temporarily install the charger with both mounts so that we can locate the mounting holes at the opposite side. The brackets at this side will be mounted to the motor mount at the gearbox side. With the holes marked, they can now be drilled out. After checking the fit of all four bolts, and with the brackets painted, the charger can be installed. After tightening the 4 bolts that connect the brackets to the frame, we can tighten the 4 bolts that connect the bracket to the onboard charger. With the charger installed, we will next install the related wiring harnesses, but first we'll look at this on the wiring diagram. There are 3 harnesses associated with the onboard charger. These are the J1772 harness, which connects the charging plug to the onboard charger and to the charger control harness, the charger control harness, which connects the J1772 harness and charger to the BMS and CAN bus, and the high voltage charger harness, which delivers power from the onboard charger to the control box and ultimately to the batteries. Taking these one at a time, here is the J1772 plug and associated harness. The J1772 plug has 3 high voltage lines taking power, neutral, and ground, coming from the wall charger going to the onboard charger, as well as 2 low voltage lines called control pilot and proximity pilot to the BMS via the charger control harness. These lines provide communication between the wall charger and BMS to ensure that the J1772 plug is connected and that the wall charger and BMS are communicating. The charger control harness delivers power, ground, CAN connections, and high voltage interlock connections from the control box to the onboard charger, in addition to the 2 J1772 lines just mentioned. Note the 120 ohm resistor between CAN high and CAN low, since this is the end of the CAN bus, as mentioned in the last episode. Note also the connection of the ground line to both the ground pin on the OBC connector as well as to the ground line from the J1772. This is necessary so that the charger and BMS have the same voltage reference. And the charger high voltage harness here is pretty simple, just the positive and negative lines running between the OBC and control box, where it is then connected to the positive and negative terminals ahead of the contactors as shown in episode 14. Note that the low voltage lines between the OBC, the J1772, and the charger control harness have these connectors between them in order to keep these harnesses separate, less complicated than a single larger harness, and individually replaceable if necessary. These will use the same Amphenol connectors that I used between harnesses in the last episode, and since I didn't really show the installation of these connectors in that episode, I'll show that here. The 2 connectors that I will be using here are a 3-pin connector and an 8-pin connector. In the last episode, I also used 12-pin and 2-pin. I've already prefabricated the harness, minus these interface connectors. The connectors have a female shell in which you install male pins into, and a male shell in which you install female sockets into. First, here is the female shells for both the 3-pin and 8-pin connectors on the charger control harness with the male pins installed on the wires. The connectors have optional boots or back shells that slide over the connectors, and I am then heat shrinking these boots onto the group of wires. For now, I'm just loosely installing these until after testing in case there are any problems requiring wires to be pulled and repositioned. The connectors have their pins marked so that the lines can be correctly placed at both ends of the connectors. For some reason, the 3-pin connectors label their pins as A, B, and C, whereas the 8-pin and all other size connectors use numbering. The connectors also have a wedge lock that is installed in the connector that ensures that the pins are locked in and cannot be pulled out. Now here are the male shells for the 3-pin connector at the J1772 harness and 8-pin connector for the charger control harness with female sockets installed on the lines. The wedge lock for the male size not only locks the pins, but also holds the gasket in place so that it does not come loose when disconnecting from the female connector. Pulling these pins out to rearrange them is very easy. First, you need to remove the wedge lock. For the male side, this is handled by prying it off from below. The pin can then be removed by prying back the pin lock inside while simultaneously pulling on the associated wire. At the female side, the wedge lock can be removed by pulling out with a pair of pliers. So with the connectors installed, we can now install the harnesses. Next, we will take the harnesses for the DC to DC converter. As mentioned, this will be mounted to the body in the battery box below the passenger seat. This will require some ventilation in the box, which we will cover in a future episode. We will be making these connections on a temporary basis and will then finalize these connections later after the body is installed and the equipment is permanently mounted. These lines are pretty simple, just a pair of high voltage lines here and a pair of low voltage lines, which are just CAN low and CAN high. And then here are the 12-volt connections to the battery. You can see here that there is an optional 12-volt positive enable connection, which is an alternative to CAN enable, and I have left a connection for that off the body harness as an option, but this should not be needed with our CAN setup. And now here are the actual connections. So here down at the ground now, in the approximate area where the battery box will be relative to the rest of the vehicle. Here's the control panel. It'll be raised up about here, right inside the body, but it's about the same location that it would be. We have the battery, also same location that it would be, and we have the DC to DC charger. This is actually going to get mounted like this inside the battery box, somewhere up in here. So here we have the high voltage lines coming from the master control, and for now you can see I've just temporarily wire nutted those into the connector, so we can connect this for testing. This will get removed later and shortened up to the right length and finalized after the body goes on and this gets installed permanently. But for now this will just be plugged in temporarily for testing. And then same thing with the low voltage. This is really just CAN coming into the CAN connection here. This will eventually be shortened. I'll put a new connector on up here somewhere where it's shorter and the appropriate length. Also, you can see here we've got the main positive. This will come up and connect to the battery. The main negative, which is actually going to connect to the body around here. And then I'll have another cable that connects that into the positive over here. And then you can see here is the positive from the DC to DC charger, which will come in and connect to the battery here. Same thing with the negative, I'll connect into here. I'm not going to do that quite yet. We'll wait till the rest of this is done next episode to connect these for testing. Okay, so that's it for now. Next time we will be finalizing all of the remaining EV related systems and testing all of the equipment. So that will hopefully be a really big milestone, getting the motor spinning, the batteries charged, and display working. Should be a big one. See you next time.